Hello, my name is Anirudh Menon, and today I'm going to evaluate two papers which are based on membrane fouling, cleaning, and prevention. Paper one is a chapter from the book Fouling, Infiltration, and its Remediation Methods, which are written by A. Abdul Rasul, H. Dewan, and L. Lohi. A. Lohi. From this book, I will start by talking the membrane fouling mechanism. So, in general, flux membrane decline is due to two factors, which are pore blocking and pore blocking and cake formation. In pore blocking increases the membrane resistance, whereas cake formation provides the additional layer of resistance for the permeate flow. So essentially, these two are the fouling mechanisms for ultrafiltration. Based on the fouling mechanism, now you must be wondering, how can they be prevented? Well, the fouling can be prevented by two ways: pre-treatment of the feed and membrane modification. Now, pre-treatment of the feed is really important, as that could control, as that is really needed to control colloidal, biofouling, and organic fouling. Now, for low pressure systems, so in this case membranes and microfiltration and ultrafiltration membranes, methods such as coagulation, magnetic ion exchange, and muscular enhanced filtration are the best. In coagulation, chemicals are added such as iron chloride to reduce the fouling. So in this case, reversible fouling is decreased, but irreversible fouling still exists. Whereas magnetic ion exchange uses dissolved ions or charge carriers in water, and that absorbs to the polymeric bead. So magnetic ion exchange can be used in exchange with coagulation, and that will remove 90% of the natural organic matter. Then muscular enhanced filtration is a emerging technique, and nothing much has been understood. So more research has to be done. Now, fouling materials can only be cleaned by two ways, which is backwashing, and if using chemical cleaning, then enhanced backwashing. In backwashing, the water is reversed, the direction of the water flow is reversed, and permeate is used to remove the fouling materials. Enhanced backwashing is similar, except chemicals are added to the water. So chemical cleaning is essential to industry, and chemical cleaning restores the permeability of the membrane. Now, the type of chemical cleaning required will depend on the type of membrane you use. In mechanical cleaning, sponge balls are used to clean the foulings. Now, I will talk about paper 2, which is an article on fouling and cleaning procedures for composite polyamide RO membranes by a company called Nito. So, in general, some of the elements of the RO membrane can be subjected to foulings by suspended or soluble materials. Some of the common examples of fouling are calcium carbonate and polymerized silica scale. So the nature and rapidity of the fouling depends on two factors, which are quality of the feed water and system recovery rate. So in short, the fouling is progressive, and if it's not cleaned, the RO membrane will be impaired. So parameters that needs to be controlled, it needs to be constant when doing cleaning are permeate flow, permeate back pressure, recovery temperature, and feed TST. So cleaning is done every 3 to 12 months in general for RO membranes. If doing more than that, then the capital cost is increased. So obviously, in this case, chemical cleaning is also done in this case, but again, factors needs to be taken into account. So when first time cleaning, Contact the RO manufacturer to find out what kind of chemical is required for the cleaning. Then hydronautics recommend that the operators must observe a sign of fouling before deciding on cleaning agent and cleaning protocol. For low fouling, low pH systems can be used to remove the low fouling. But for more complex fouling, other processes has to be taken into account.